Alrighty, here is the key to your review. We start with inverses, which we actually did at the end of last 6 weeks, but it wasn't on that last test. So remember, for inverses, what we are doing is we are exchanging x and y. So I'm going to set this equal to y. Then this is going to give me y plus 3 cubed equals x. Then I solve for y. So I need to take the cube root of both. So I get y plus 3 equals the cube root of x. Then I'm going to subtract 3. So y equals the cube root of x minus 3. And that is your f inverse of x. So yeah, it equals y for the inverse, but make sure that you have it labeled and it is actually your inverse. Oh, we could put it here too. Cube root of x.
May I have your attention, please?
minus 3. All right, so then we're supposed to verify graphically, which means we need to graph both of them. So my original one is this. We'll graph it in purple. It is a cubic. Your cubics look like this, right? So I can start at 0, 0. The only change is a translation to the left. So I go left, 1, 2, 3. Make my little point there. Since there were no stretches or compressions, here are two other points from the anchor points. Then there are 5 anchor points. There should be 5 things that are plotted, or 5 points that are plotted here. So for my parent function, I would have been at 2, 8. So 2, 4, 6, 8. And then I translate to the left, 1, 2, 3. Which means to use symmetry, be down over here. So here is my original function. All of the pertinent points plotted. Then I'm going to graph the inverse, which is a cube root. So my cube root looks like this, right? So in that case, it's just going to move down 3. So I got 0, 0. I'm going to go down 1, 2, 3. Then these other 2 points here. So another anchor point would have been at 8, 2. But I go down 1, 2, 3. And so from over here, right there. And this is what this one looks like. Then I also need to draw in my y equals x. Oh, okay, I cannot do that on this board, sorry, without basically a straight edge. It looks like I'm cheating, but you would use a straight edge too. So you can make it a dotted line. I'm just going to draw it in because otherwise it's going to look really bad. And there you go. Okay, so they all intersect on that same point there. I have all the important points actually plotted where I can tell you plotted some points. And then the line y equals x. Then we need to verify it algebraically. So I have to find f inverse of x. And if you renamed that like g of x to make it easier, that's fine. But I'm going to take the inverse and substitute it in. So when I substitute the inverse into there, this is going to give me the cube root of x minus 3 plus 3 cubed. So minus 3 plus 3 zeroes out. And then the cube root of x cubed is going to give me x. Then I need to do the inverse of f inverse of the f of x. And take f of x, which is x plus 3 quantity cubed, substitute it in there. So I get the cube root of x plus 3 cubed, and then minus 3. So in this case here, the cube root of this is going to give me x plus 3 minus 3, and that equals x. So then I can say, yes, they're inverses, because I get x both times. So there's 3 main parts. You got to find it, you got to verify it algebraically, and verify it graphically. Okay, so now we are going to graph this function. This is 2 times x to the 4th. Now these were our power functions. Remember, all of the even power functions are going to resemble quadratics, and all of the odds are going to resemble cubics. So for a quadratic, I got 0, 0. Even for so the parent function here would be just x to the 4th. So my anchor points would be 0, 0. Well, if all that 2 does is stretch it, it's still 0, 0. Another anchor point would be 1, 1. And then I have a vertical stretch of 2, so I go to 2, put those points. For my original, okay, my parent function, when I substitute in 2, this would give me 2 to the 4th. So 2 to the 4th would be 16, right? And then I'd have 6, so I'll be over here at 216, and then I'd have to double it. So I'm like way up there. That's still important for me to know, because that helps me with how wide this swings out. If I'm going to be at 2 and way the heck up there, then that means this is really skinny. It's coming in right like that. So got that. So our domain, negative infinity to infinity. Your range, 0 to infinity. And we include 0. Cannot be missing that stuff anymore. X-intercept is 0, 0. Y-intercept is 0, 0. Increasing, I'm increasing from 0 to infinity. And I'm decreasing from negative infinity to 0. The symmetry, I have symmetry about the y-axis. There are no discontinuities. Now, when you're flat out asked for in behavior, then it needs to be written in that sentence format. If you're using it yourself just to know what to graph, that's when we can use the arrows. So here we need to say, as x approaches infinity, f of x approaches, and as x approaches negative infinity, f of x approaches. All right, so as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches infinity. Okay. All right, so for the next one, we're going to find the zeros of the following two equations. And make sure that you are reading these instructions and doing what it's asking you to do on these, and not just assuming that, nobody's asking me to find all the possible rational zeros or do any of that stuff. Just find the zeros. So here, I told you to make a correction. This should be 37x squared. So when you have a quartic, if it's a trinomial and you've got x to the 4th and the x squared here, you can try and factor it just like you would a quadratic, right? So if this was a quadratic, then I'd do 36 times 1, which gives me 36, so I can do my grouping. So this gives me 36x to the 4th. I need two numbers that are going to multiply to give me 36, combined to give me negative 37. So that would be a negative x and a negative 36x. But it wouldn't be x, it would be x squared, because I got to be able to combine these back together to get this, and then plus 1. Then I can do my grouping. So out of this one, I can factor out an x squared. That's going to leave me with 36x squared minus 1. Out of this, I can factor out a negative 1. So that leaves me with 36x squared minus 1. So then this is x squared minus 1 times 36x squared minus 1. Those are both difference of squares, so to factor it completely, even though I could find my zeros from here, I want them factored completely. I do not know how many times I have to say that. So this x minus 1 becomes x plus 1, x minus 1. This becomes 6x plus 1 and 6x minus 1. This is your fully factored form. Then I can find my zeros. Okay. So this is going to give me plus or minus 1, and this is going to give me plus or minus 1/6. Okay. All right, so then this next one. This is a cubic, but I do have a GCF that I can factor out, so I'm going to factor out my x, and this is going to leave me with x squared minus 5x minus 14. So then that's a quadratic that I can factor. Right? So x, this is negative, so these have to be opposite. The only two things that are going to multiply to give me 14, it's either 1 and 14 or 2 and 7. So to get this, if I had a negative 7 and a positive 2, that would work for me. So that is my fully factored form. And then my zeros are going to be negative 2, 0, and 7. There we go. All right, on to the second part. It says, given the graph of the polynomial function, determine whether A, the degree is even or odd, and the leading coefficient is positive or negative. So if it has the same in behavior, meaning it's like up, up, or down, down, that would be the same type of thing as what a quadratic would look like, which means this has a an even degree. Okay, so it's an even degree. And since it's up, up, just like an even quadratic would be, then it has a positive coefficient. Then here, if they're opposite, it is odd. Odd is opposite, so odd degree. You should know what a positive, or what a cubic parent function looks like, so that would be the positive. This is opposite of a cubic parent function, which means this would have to be a negative coefficient. Okay, so now we're going to give the zeros their multiplicities and describe the effect on the graph. Oh, somehow part of the G has disappeared, but graph. All right, so here the first one's already factored for me. That's great. So I just got to find my zeros. So the smallest one is -4, then -5/2, then 1. Okay, so -4, -5/2, and 1. Multiplicity. All right, so the -4 came from here. There are 2 of them. Multiplicity is 2. -5/2, multiplicity is 5. The 1, there's nothing there, so it's like a 1. Multiplicity is 1. When you have an even multiplicity, when we're graphing, yes, we can think about bounce, but that's not the real word. When it bounces because it is tangent to the axis there. The odd, except for 1, is your wiggle. The real word for wiggle is point of inflection. If it's just a multiplicity of 1, yes, that's odd, but that's not a point of inflection. We don't put nothing, we don't put linear. That just means it goes right through the axis, so this is a pass-through. Okay, so this one, next one, we have to factor. So you want to factor out the GCF, not just the CF. Yes, I can factor out an x cubed. That's beautiful. I need to do that. I can also factor out a 3. So this gives me 3x cubed times, and then this is x squared plus 4x plus 4. Okay, that is a perfect square trinomial. I can take half of this and square it and get that. So that tells me exactly what it is. It is clear to me that not everybody recognizes that, and you're factoring it like you would factor anything, which is fine. It's not wrong. So I'm going to do it that way. So I get 3x cubed, and then when you factor this, you'd get x plus 4 and x plus 4. Here's what we don't do. I don't put that -4 is a 0 and with a multiplicity of 1 and write that down twice, because I'm not finished with this. Yes, this is factored, but it's got to be factored and condensed correctly. So that means f of x is equal to 3x cubed times x plus 4 squared. Then you can see your multiplicities like you do over here. This is my fully factored form. My zeros are -4 and 0. So -4 and 0. The multiplicity for -4 is 2. The multiplicity for 0 is 3. So that means this is tangent, and this is a point of inflection. All right, now we're going to divide using long division or synthetic division. Do whichever you want, as long as it makes sense and you can figure it out. I would suggest on this one, since this is what we are dividing by, that is something I can use synthetic division for. So personally, I would use synthetic division. Again, you could use long division if you wanted, whatever. So on the outside here, then here is going to be -5. The coefficients, I'm going to have 1, 1, -17, and 15. Be very careful of any placeholders that you would have to have if you had any missing terms. So then I'm going to bring down my 1. This is -5, -4, +20, 3, -15, and 0. So I'm left with this. That's going to be a quadratic because there's 3 terms. So I got this question a lot today. Do I keep going? Do I find the zeros? What do I do? What you do is you read the directions. The directions say divide using long division. It says nothing about zeros. This doesn't say f of x, nothing. You've divided. You are done. Your answer to the division is x squared minus 4x plus 3. Okay, you have to be able to read the directions and understand what it's asking of you. So then on this next one, I'm going to divide here. Well, this doesn't fall under my general synthetic division rules, so I'm going to do long division here. I'm going to take 3x minus 2, and it's going to divide into 9x to the 4th. I'm missing an x cubed term, so I'm going to put plus 0x cubed plus 5x squared minus, oh, and look, I'm missing an x there also, so I'll put plus 0x and then minus 12. So 3x goes into 9x to the 4th. That would be 3x cubed times. So I multiply these and I get 9x to the 4th. And then minus 6x cubed. I'm subtracting, so I change the signs on both. This is going to zero out, and this gives me 6x cubed plus 5x squared. 3x goes into 6x cubed, 2x squared times, so plus 2x squared. This gives me 6x cubed minus 4x squared. And then this is minus and plus. So then these zero out, and this gives me 9x squared plus 0x when I bring that down. 3x goes into 9x squared, a positive 3x times. So this gives me 3x. Oh, sorry, no, it does not. When I multiply 3x times 3x, I get 9x squared minus 6x. I change the signs, be very diligent in that. These zero out. This gives me 6x minus 12. 3x goes into 6x, a positive 2 times. So 2 times 3x is 6x. 2 times a negative 2 is a negative 4. Then I change the signs on both. This gives me a negative 8. Okay, and that's my remainder. Again, the directions said divide, and that was it. If I have a remainder, I can't factor and get zeros anyway because this isn't a factor. So my answer then is 3x cubed plus 2x squared plus 3x plus 2 plus a remainder, which happens to be negative 8 over 3x minus 2. All right. Next one, we are going to sketch this polynomial. So there's some things I need to know. I didn't put all these blanks here, but these are the things we need to think about. We need to think about what is the degree. Well, this is 2, 3, 4. So the degree is 4. Okay, so your degree is 4. What that tells you is your end behavior. This is a positive leading coefficient, so your end behavior looks like this. Okay. I also need my zeros. Okay. And since it doesn't actually say like 0 or x-intercept, whatever, you can write it however you want. So my zeros, the smallest one is going to be 0, and then 2, and then 6. I also need my y-intercept. These are all pieces of stuff I need. So in order to find that, I substitute 0 into each one of these, making sure I take care of that squared. But once I substitute 0 in there, it's taken care of. If you have an x-intercept that's 0, your y-intercept is 0, 0. Okay, then we also need to look at your multiplicities, right? This has a multiplicity of 1. This has a multiplicity of 1. This has a multiplicity of 2. So at this 0 here, the multiplicity of 2, that is when it's tangent to the axis, so you're going to have a bounce there. There's no points of inflection, so we don't wiggle, we just bounce. And you don't never bounce and wiggle at the same time. Okay, so to put these on here, I've got to go to 6. So 1, 2, 3, 4, 5, 6. Oh, that was kind of bad there. You want them spaced out kind of evenly. It doesn't have to be perfect, but oh my gosh, what the heck. There we go. And then 1, 2, 3, 4, 5, 6. I have zeros at 0, 2, and 6. Okay? And it's up, up, and I got to bounce at 2. Okay, so I'm bouncing right here. Like, again, some of us you write that stuff down over there, but then it doesn't happen on your graph. You also need to make sure that your y-intercept is labeled if it's not 0, 0, okay, and that you can hit that. So I start from up here. I have to pass through this. I come back up, and I bounce, and then I come back down, then I have to come back up through this. Be very careful. The only times that you get to touch the x-axis when you are sketching is at wherever your zeros are. So let's say that you missed the bounce, right? So you come down, you come back up, you're up here, and you know you've got to end up going up, so you come back down so you can go back up. Well, you don't get to go down through there. It doesn't work that way. You have to be able to cross at only at the x-intercepts. Okay? So that is your sketch of your polynomial. All right, so now, again, we're dividing using long division or synthetic division. Well, I really only have a choice here. My only choice here is long division. So x squared minus 5x minus 5 is going to divide into 2x cubed minus 11x squared minus 5x plus 4. All right, so x squared goes into 2x cubed 2x times. 2x times x squared is 2x cubed minus 10x squared minus 10x. Then I change the signs. These zero out. This gives me negative x squared plus 5x plus 4. So x squared goes into negative x squared negative 1 times. So then negative 1 times x squared, then negative x squared plus 5x plus 5. Change the signs on each one of them. The careless mistakes are happening from those of you that are stubborn and don't change your signs. These zero out and these zero out, so you are just left with negative 1. Again, all it says to do is divide. So my answer is 2x minus 1 plus negative 1 over x squared minus 5x minus 5. That is your answer. And there's a reason we care about those remainders too. We're getting there pretty soon. Next part, use the remainder theorem to evaluate. Okay, evaluate f of x at x equals c. Which means that when I'm done with this, my answer to this first one is going to be f of 3 equals something. And I do that using synthetic substitution. And since c equals 3, the factor would be c minus 3. So I'm using this. This is telling me what I use on the outside there. So I got a 3 here. This gives me 1, negative 4, negative 1, and 6. Bring this down and get a 1, 3, negative 1, negative 3, negative 4, negative 12, negative 6. So f of 3 equals negative 6. It's that easy. It's just the way to evaluate. So then I move on to this one. This is what goes on the outside, negative 2. My coefficients are 4, negative 3. I don't have an x squared term, so there is a 0 there. 7 and negative 11. Bring down the 4. This gives me negative 8, negative 11, positive 22, 22, negative 44. Then that gives me a negative 37, right? 44 minus 7, yep. And then negative 2 times 37 is going to be a positive 74. Positive 74 and negative 11 is going to give me a positive 63. So f of negative 2 equals 63. Alrighty. Then 1 goes out here. You get 1, negative 6, negative 3, 2, and 2. Bring down my 1. 1, negative 5, negative 5, negative 8, negative 8, negative 6, negative 6, negative 4. So f of 1 equals negative 4. Then, last one of these, negative 3 goes out here. I have a 2, a 5. I do not have an x squared term, so that's a 0. Then I have a 3 and a 4. Bring down the 2, get -6, -1, 3, 3, -9, -6, 18, 22. So f of -3 equals 22. All right, next part. Use the factor theorem to determine, oh lordy, I lost the E here, determine which binomials are factors of the functions below. So we're using synthetic substitution. Is x plus 1 a factor of this? I don't know, and I don't want to factor it to figure out, right? So since it's x plus 1, -1 goes out here. My coefficients are 2, -3, -17, and -12. This gives me 2, -2, -5, 5, -12, 12, and 0. Okay, so what this means then is that x plus 1 is a yes. And since it is a yes, I have reduced it down some, which means when I move on to my next one, I get to use the reduced version, which is a little smaller. So on the outside is going to go a 4. And then I have 2, -5, and -12. Bring down the 2, this gives me 8, this gives me 3, this gives me 12, this gives me 0. Well, that's great news. That means this one works too. So x minus 4 is a yes. So now I get to use the reduced version yet again. I'm going to put this -3 out here, and I get 2 and 3, right? So I bring down my 2. 2 times a -3 is a -6. That's -3. So this is going to be a no. X plus 3 is a no. Right. Moving on to the next one. I'm going to start with my x plus 2. So I'll have a -2 on the outside. My coefficients here are 1, 4, -8, -35, and -12. Bring down my 1, -2, 2, -4, -12, 24, -11, 22, and 10. So that means that x plus 2 is a no. So I do not get to use the reduced form because I didn't reduce it. I got to use my originals again, and I'm moving on to x plus 4. So this is going to be a -4. And I still use 1 and 4 and -8, -35, -12. Bring down the 1. This gives me -4, 0, 0, -8, 32, -3, 12, and 0. So that's good news. That tells me that x plus 4 is a yes. And since it's a yes, I get to use the reduced version on the next one. So this is going to be a 6, and this time I'm using 1, 0, -8, and -3. Then I get 1, 6, 6, 36. It's going to be a 28, right? And then 6 times, all right, yeah. So then 6 times 28, 6 times 20 is 120. 6 times 8 is 48. So this is 168. And then -3, it's 165. So that means that x minus 6 is a no. All right, last page. We're going to use the rational zero theorem to list all possible rational zeros. And all it says, some of us missed this part reading on the homework, list them. It doesn't tell me to find them right now. It just says list them. So when I do that, I am looking at the constant term and the leading coefficient, which happens to be 1. When the leading coefficient is 1, I don't even really have to set up a fraction. I just need all the factors of 42. So my possibles are, so when I go through 42, obviously 1, well, 2 works. 42 is divisible by 3. Is 42 divisible by 4? The answer to that is no. Is it divisible by 5? No. Is it divisible by 6? Yes. So plus or minus 6 and plus or minus 7. Now 6 times 7 is 42. So these two match up. I need to match up what goes with 3. So 3 goes into 42 14 times. So plus or minus 14. And then 2 would be plus or minus 21. And then 1 would be plus or minus 42. Okay, so there are the possibilities there. Then I move on to this one. Well, once again, leading coefficient is 1. That's beautiful. So your possible zeros are just going to be the factors of 15. Plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. This next one. Okay, so here's other mistakes. And nobody even said anything to me until 7th period. But yes, there are exponents missing, and I'm so sorry. I know I fixed this before I printed it, and then it disappeared again, and I don't even know why. But this should be x to the 4th, and this right here should be x cubed. And actually down here, this one should be x cubed. I kind of figured maybe nobody said anything, because by the time you got to that, you were like, oh yeah, clearly this is another mistake, and you just figured it out. I hope that's the case anyway. All right, so here I'm using the constant term and the leading coefficient. So I got to set up a fraction here because I have more than one thing. So the numerator is the factors of the constant term. So I get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. All over the factors of 3, which are plus or minus 1 and plus or minus 3. So my possibilities then are, so 1 over 1 is 1, plus or minus 1. 1 over 3 is plus or minus 1/3. Then we move on to 2. 2 over 1 is 2. Then we move on to, well, then 2 over 3 is 2/3. Then we move on to 3. 3 over 1, plus or minus 3. 3 over 3, which is 1. I already have that. So then I do 4. 4 over 1, plus or minus 4. Then 4 over 3, plus or minus 4/3, which I don't have yet. Then I move on to 6. 6 over 1 is 6. 6 over 3 is 2. I already have it. 8 over 1 is 8. I don't have that. 8 over 3 is 8/3. I don't have that. Move on to 12. 12 over 1. 12 over 3 is 4, and I have that. 24 over 1 is 24. And then 24 over 3 is 8. I have that. So there's lots of possibilities here, but not as many as it really looks like there should be from there. Okay. Then this last one of these, I have the constant term, my leading coefficient. So I have to have a fraction here. Plus or minus 1, plus or minus 2. 28 is not divisible by 3, but it is divisible by 4. Not 5, not 6, but 7. Plus or minus 7, plus or minus 14, plus or minus 28. All over the factors of 2, plus or minus 1, plus or minus 2. So my possibles here are 1 over 1, plus or minus 1. 1 over 2, plus or minus 1/2. 2 over 1, plus or minus 2. 2 over 2, that's 1. I already got it. 4 over 1, 4 over 2 is 2. I already got it. 7 over 1, 7 over 2. 14 over 1. 14 over 2, I've already got 7. Then 28. 28 over 2 is 14. I've already got that one. So these are my list of possibilities that I may have to use to test things to figure out my zeros, right? So let's look at this next one. It says find all zeros and given, it says and given, Lord, and give the complete factorization of the function. Use the rational zero theorem in division when necessary. When necessary. If I could factor this thing right now, I would factor it and not worry about testing anything. I'd still list my zeros because I think it says to do that, but I can't. So I can tell if I start to try and factor by grouping, like, it's not going to work. But if I could, then factor it, and you may not have to test anything. But since I can't do that, then I'm going to have to figure out my possibilities and go through and test some things. So I'm using 6 and 5. So that means I get plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, all over plus or minus 1, plus or minus 5. So my possibilities then are 1 over 1, 1 over 5, 2 over 1, 2 over 5, 3 over 1, 3 over 5, 6 over 1, and 6 over 5. Okay, there are my possibilities. So I have to start testing them. And I only have to reduce it down enough to where I could actually factor. So I'm going to start with 1. And my coefficients here are 5, 12, 1, and negative 6. So this is 5, and then 5, and then 17, 17, 18, 18, and 12, which tells me positive 1 does not work. So I move on to negative 1. Use 5, and 12, and 1, and negative 6. So I bring this down, and I get 5, negative 5, 7, negative 7, negative 6, positive 6, and 0. So that means negative 1 works, which means, because some of us are messing this stuff up, that x plus 1 is my factor. So now that I've done that, I didn't just divide it out and it disappeared, right? I divided it out, and I get that f of x is equal to x plus 1 times the rest of this, or the remainder part there, in order to get this. There's 3 terms, so it's quadratic. It'd be 5x squared plus 7x minus 6. Okay? So then if I can factor this part, great. If I can't, then maybe I have to use a quadratic formula, or maybe I have to keep testing. But if I have a quadratic, I shouldn't have to keep testing. So if I can factor it, 5 times a negative 6 is a negative 30. So 2 factors of negative 30 that could combine to give me 7, yes, I can factor that. So that means I get x plus 1 times 5x squared. Okay, so in order to do my grouping here, this would be a positive 10x and a negative 3x. Those are going to multiply to give me negative 30, combine to give me a positive 7, then minus 6. So then I get x plus 1 times, so out of here I factor out a 5x, I am left with x plus 2. Out of here I factor out a negative 3, and I'm left with x plus 2. So then this gives me x plus 1 times 5x minus 3 times x plus 2. So now it is completely factored. F of x, this is my fully factored form, and then I find my zeros. So my smallest one is going to be negative 2, then negative 1, then 3/5. Okay. All right, let's move on to the next one. The last one, actually. And I've got this right here. Can I factor it? It's 5 terms, so I'm going with no. I've got negative 45 and 2, so I need to do a fraction. My factors of 45, plus or minus 1. 2 doesn't work, but 3 does. 4 doesn't work, but 5 does. 6 doesn't work. 7 doesn't work. 8 doesn't work, but 9 does. And 15 does. And 45. All over plus or minus 1 and plus or minus 2. So then my possibilities here. All right, I've got 1 over 1, 1 over 2, 3 over 1, 3 over 2, 5 over 1, 5 over 2, 9 over 1, 9 over 2, 15 over 1, 15 over 2, 45 over 1, 45 over 2. Okay, so these are my possibilities. Some prettier than others, right? So I'm going to start with 1. So start with 1, and my coefficients are 2, 15, 31, negative 3, and negative 45. Then this becomes 2, 2, 17, 17, 48, 48, 45, 45, and 0. That's amazing. Okay, so 1 works, which means that x minus 1 is my factor, right? So f of x is equal to x minus 1 times. Then I'm left with this. Is 1, 2, 3, 4 terms, which means that it's a cubic. So I get 2x cubed plus 17x squared plus 48x plus 45. All right, so can I factor that by grouping? And the answer to that is no, because the only thing I can factor out of here is an x squared, so that'd leave me with 2x plus 17. So if I factored a 24 out of here to get the 2, I can't factor 24 out of there. So grouping isn't going to work. So since that's not going to work, I have to continue testing numbers, but I get to use the reduced version. I've already done 1, so now I need to do negative 1. And I get to use this, 2, 17, 48, and 45. So 2, negative 2, 15, negative 15, 33, negative 33, 22. So that's a big no on that. So I've been through both of those. I could do the 1/2, but I think instead I'm going to move on to the 3, so I don't have to deal with fractions. So I'm going to use 3, and this gives me 2, 17, 48, and 45. So 2, 6, 23, 69, 117, and then 3 times 117, that's going to be 330 and 21, so that's going to be 351. Add those together, and I get 396, and it's pretty safe to say that 3 doesn't work. So that I still have room here to do the rest. I'm going to move over here. I'm going to try negative 3. Still using those same numbers, 2, 17, 48, and 45. So bring down my 2. This is a negative 6. This is 11, negative 33, and then that's going to be 15. Then this is going to be negative 45 and 0. Well, that's exciting. This works, so this is x plus 3. Which means now that I have factored this more, right? Like if I multiply this back together, I get my original. Now, I can't lose this x plus 1. He's still there. I'm sorry, the x minus 1. But now I have this x plus 3 that I also have because I factored it out of this, and this is what I'm left with here. And that's 3 terms, so that means it's quadratic. So I get 2x squared plus 11x plus 15. So then I have to figure out and see if I can factor this. Well, 2 times 15 is 30. So can I find 2 numbers that multiply to give me 30 and combine to give me 11? Yes, I can. So this is x minus 1 times x plus 3. If I'm going to do grouping, this is going to give me 2x squared. The 2 numbers would be 5 and 6, plus 5x plus 6x plus 15. So then to do my grouping, x minus 1 times x plus 3. Then out of this, I'm going to factor out just an x. That's the best I can do there. X, so that's going to leave me with 2x plus 5. And out of this one, I can factor out a 3. And that's going to leave me with 2x plus 5. So then, when it's all said and done, I get x minus 1 times x plus 3 times x plus 3 times 2x plus 5. But wait, there's more. Yes, this is fully factored, but then I'm going to condense that because there's two of those. So f of x actually equals x minus 1 times x plus 3 squared times 2x plus 5. This is the fully factored form. Then I can find my zeros. X equals, let's see, this is going to give me a negative 3. I actually get negative 3 twice, but I only put it once. And then I'm going to get negative 5 halves and 1. And that concludes your test review. Remember that I am also grading your ISNs, so make sure that that is ready. Everybody should get 100 on their ISN. You get frustrated when y'all don't. It's easy. Do your notes. Put them in. I'm not asking that much. You have potential to do very well on this test, so make sure you're prepared.